One of the critical insights about companies like Amazon and software-based organizations is that the design principles that drive success are fundamentally different than they are for industrial companies. This idea might best be embodied in the phrase, software is never done. Immense effort and resources go into building a physical system, and yet more resources are required to change one after it is built, not to mention the need for the suitable working environment. Software systems, on the other hand, can be built and changed at the press of a button. All that's needed to push changes to a modern system is a connection and a design pattern that allows continuous updates. At the same time, the solution space for software systems is virtually limitless, unbounded by the laws of physics that dictate the form and function of physical systems. As a result, the systems engineering process we have built over the last 150 years is not optimal for the design of software-based systems. Instead, iterative design approaches have come to dominate software design philosophy. Instead of releasing a single monolithic software product, software system capabilities can be built out in small additions and changed over time. Taking advantage of the fact that software is so easy to refactor, a single change may go through multiple iterations, each improving on the last, to optimally meet the needs of the user. The organizations that thrived in the early digital era recognized that software systems represent drastic changes in design, capabilities, economics, and logistics when compared to physical systems. And they innovated entirely new processes and business models to account for that fact. On the other hand, industrial giants like GE recognized that they needed change, and still, despite their efforts of their leadership to make GE Digital a success, they failed to make the transition. This has serious implications for how the Navy and Marine Corps need to change, how we need to change when it comes to engineering and operating. When we design a ship, we try to think about every scenario and edge case and combine the design process with rigorous testing and requirements, because once we lay down a ship's keel, it is extremely difficult and costly to re-engineer its physical design. A defect discovered in the hull of the ship after it's been launched, for example, is an engineering disaster. We have developed a world-class engineering acquisition process to deal with these issues, but to apply the same process and principles to digital systems would be a mistake. Applying industrial error principles to digital error technologies is a recipe for failure. When powerful new technologies cause a paradigm shift, organizations adapt or face irrelevancy.